Hi. Some learners have asked for the answers to this homework about optics that we actually did a couple of weeks ago. I apologize for getting it out now, but I really wanted to do it in a descriptive manner in a presentation format. So we're going to go through this today and hopefully this provides some insight. So what is a mirror called that curves inward? So that one, what I remember is when I think of it being like a spoon, the part that you can, if you could go into it, that's like a cave. So if it curves inward toward the center, it is concave. What is a lens called that curves on the outside toward the middle? So it's curving this way and this way. And I actually still go back to the idea of spoons. So I think the inside is the cave. The outside is the opposite. So we have concave. And then you have convex. So the outside on the mirror would be convex. And the outside, if you have a curving this way, is convex. That's the way I think of it. And the opposite is when it curves this way. It's pretty bright on the eyes. That's diverging. So I kind of look at what's on the outside. Is it a cave aspect? And that one has the opposite term. In the mirror aspect, it's concave. It's diverging when it's a lens. But the convex stays the same. So you can have convex for a mirror if you're looking this way, or you can have convex this way. It also stands for converging, convex or converging. Okay, same thing. Now, so what is a lens that curves outward toward the middle on both sides? And that's the one that we just covered. So this is convex or converging. Which lens, this kind of does the opposite, which lens converges light? Well, the converging lens. Okay, kind of makes sense. And which lens diverges light? That is diverging lens. Is the image in a concave mirror upside down or right side up? Well, you might remember if the mirror curves this way, the image, you've got an object this way, the image will look upside down. Okay, and we do some work on how to show that in the next few slides. Okay, so now we have an object in front of a concave mirror, and we're going to do some work on this. So what do we have here? So we have concave mirror, and we have a 5-inch object. So you have the height of the object equals 5 inches. And it says it's 15 inches away, so distance of object, it's kind of painful there, it's 15 inches. And what else does it say? It says the radius of curvature is 20 centimeters, 20 inches, sorry. So what do we have? The focal length is going to equal the radius of curvature over 2, which is going to be 20 divided by 2, which is 10 inches. So what do we have? We have a focal point at 10 inches. Okay, now we have this lovely formula to use. 1 over distance of object plus 1 over distance of image is equal to 1 over focal point. Now this is this fun one. It's not all that hard of a formula. We have to know which things are positive and negative. And I get a little stuck on thinking about that, to be honest. But I draw out my object aspect. So we draw a line straight across, parallel, just a little hen scratch as such. And then we draw, oh, where's my pen going? There we go. It's working better now. And then we draw another one straight through here and right across. Wherever these two lines cross through, that's where your image will be. So what do we have to know? We know that the image is going to be upside down. And we know that the image is in front of the mirror, which is kind of weird to think about, I know. But since it's in front of, it means it's positive as well. So when we rearrange this, what do we have? So we have 1 over distance of the image is equal to 1 over the focal point minus 1 over the distance of the object. And what do we have? 1 over focal point. The focal point that we're using crossing through is in front as well. So pointer options, laser pointer, there we go. Oh, that switched my mode up. Just one sec. That's kind of funny. I'm still learning how to use this while I'm recording myself. So 1 over focal is 1 over 10. And 1 over the distance, what was the distance? It was distance of the object was 15. So what do we have? We have 1 over the distance of the image is equal to 1 over 10 minus 1 over 15, and everything's positive. Now, you can solve this using a calculator. That is okay to do. But you could also, if you're comfortable with the math, you can multiply this out. So if you get a common denominator, if you remember fractions, what do you have? 10 times 15. So on the top, you can have 15 all over 150 minus 10 all over 150. And you're going to get 5 all over 150, which will give you 1 over 30. Now you might know that you can flip this over. So 1 over distance of image equaling 1 over 30 is also like distance of image over 1 equals 30 over 1. So the distance of the image will be 30 inches. Okay? So again, if that's kind of mind-boggling, that's okay. You can do it on a calculator. If you've done a lot of fraction work, you can probably follow along. It's all good either way. Now, we also need to know a little bit about that image. So what do we have? We have magnification. Well, where did my M go? Magnification is height of the image all over height of the object, which is also equal to negative distance of the image all over distance of the object. So in order to find out the height of the image, it's negative distance of image all over distance of object times height of object. Maybe you're comfy with that. If not, that's okay. Again, we're looking at high school physics here. So it's got some work involved here. So what do we have? The distance of the image is 30. And that's negative. Distance of the object was 15. And then we're going to multiply by the height of the object, which is 5. Well, if we multiply that out, we are going to end up with a negative 10 inches. So what does that tell us? It tells us the negative means it's going to be upside down, and it's going to be 10 inches, so it's bigger than the actual object. And what is the magnification? Magnification, height of image, all over height of object, which will be height of image is negative 10, all over the object of 5, so negative 2, which means it's going to be 2 times as large, and the negative means upside down. So that's all the information about what this image will be. Distance, height, all the setup about this. Okay, so here is our next calculation, our next problem to do. And what do we have here? Okay, so we'll get our pen going. There's our pen. It takes a moment sometimes. So what do we have? Okay, so we have a 50 centimeter high object. So height of object equals 50 centimeters. And it is placed 30 centimeters from a mirror. So distance of object equals 30. Now it says it's convex, so it's the opposite. And it says it has a radius of curvature of 20. So our first thing, which is really nice and straightforward, focal point is going to equal our radius of curvature divided by 2. So 20 divided by 2 will give you 10. So our focal point is at 10. Okay, now we get to play with this a little bit. And our first thing we can do, we go right across the top. Not a very good drawing here. And you continue this line right across too. And you have a focal point that again is on the other side as well. And you pass the line through there. Okay, you definitely use a ruler and measure out everything if you needed to know it exactly from drawing. Now, our next part we draw through, kind of weird on this one, you use the radius of curvature on this one. So our radius of curvature was at 20. Sometimes they use capital C for this. And for that one, you actually draw a line right through. It is even harder to draw, but anyway, we'll see what we can draw. Oops. I think you can get the gist of it. And again, we're not trying to make this exact for our hand scratch drawing. We could. Here is, come on, little pen, do your thing. Oh, I gotta fix it. Okay, hopefully. There we go. Oh, come on. I think it should settle out. I'm always amazed at what happens. This pen is nice, but it's not perfect. Anyway, we have our little image here, and that's what we get to figure out. So we use that same formula again. So 1 over distance of object plus 1 over distance of image equals 1 over focal point. Okay, so we are going to change this around. 1 of distance of image is equal to 1 over focal point minus 1 over distance of object. Now, we got to think about these things a little bit. So 1 over focal point. What do we have this time? We're using the focal point that's behind the mirror as such. So what do we have? We have a value that is actually, oh, I'm going to just double check. Yes, it is negative 10. And then we have a distance of object. That's positive because it's on the front of the mirror as such, of 30. Okay, and we can do the same trick that we did just a moment ago. Okay, let's see if my pen settles out. So, no, there's our 30. So what do we have? Well, we have negative 1 over 10, and we can multiply that by 3. So you can get negative 3 over 30 minus, and then 10 over 30. Okay, that's a little, oh, I messed up there. Guess what? Did you see what I did? I multiplied where I shouldn't have. So that should be 1. You have negative 3 over 30 minus 1 over 30. We're going to have negative 4 over 30. Okay, so if we do our flip trick again, we have 1 over distance of image is equal to negative 4 over 30. Distance of image, you flip it. You get negative 30 over 4, which will equal negative 7.5. Again, you could do that all in the calculator. That's okay to do too. No big deal. Now we get to figure out the magnification and all that good stuff. So magnification is height of image over height of object, which equals negative distance of image over distance of object. So height of image is going to be negative distance of image all over distance of object times height of object. And what do we have? We have negative, where's our line here? So distance of image, oh come on, is negative 7.5 times height of object. What was the height? 50. And then that is divided by the distance of the object. And if you do the math, you're going to get your height of the image, which I think I calculated already. Yeah, I came up with 12.5 centimeters. You can punch it into your calculator, see if I got it right. I don't always get it right. And then our magnification is the height of image all over height of object. Height of image, what do we have? 12.5. And then height of object over 50. And we get a value of 0.6. Okay, and that will also equal negative distance of image. So what's our distance of the image? Where did we get? Negative 7.5. So negative 7.5, which is kind of weird. Negative becomes a positive if you've done that math before. If you haven't, it's all good. And then we have the object, distance of object, which is 30. And we should be getting 0.6 again. I'm trying to see if we got that right. Distance of image, negative 7.5. Yes. Okay, so your magnification is 0.6. So it's smaller than the actual object, but it is not upside down. So there is no negative number. And we'll see. There we go. That whole part went away. So magnification less than 1, so it's smaller. There is no negative. So the image is right side up, but behind the mirror as such, which is kind of weird to think about. Okay, so when I rendered these slides over, all of the slides seem to take except for this one. It didn't play the video at the same time. So we'll do this one over again today and get it set up. So what do we have here? So we have our baseline and we have an object that is 15 centimeters. So height of object, 15 centimeters. And then we also have the distance of the object, which is placed 20 centimeters away. And then we know that it's a diverging lens. And when it's diverging, it's curved this way. And when I think back, I still go back to the spoon. Okay, this is concave, this is convex. So then a convex lens is curved this way. And so the opposite diverging would be the other way. That's how my brain works it through. And whatever trick works for you is perfectly fine. We'll put a center line here. And we also have a radius of curvature of 15 centimeters. So here's our radius of 15 centimeters. So what do we know from that? Well, then we know that the focal length is equal to half of the radius of curvature, which will give you 7.5. So we can put a focal length on both sides. And we don't know which side we're using for sure. I always have to think this through, to be honest. And focal length on both sides. Remember, our eye will be on this side of the lens. Okay. Now, what do we think about with this? To draw the image out, you will be drawing a line straight across to the center. And then really it is a perpendicular aspect here to think about, that you're going to draw a line right up from there. Okay, and then we do one other line, and the other line goes right through the center of the lens. So we draw a line from here. We're going right across. Where these two lines intersect, that's going to be the image. So what do we have? We have our lovely little formula here, 1 over distance of object plus 1 over distance of image equals 1 over focal length. So we rearrange this. We get 1 over distance of image is equal to 1 over focal length minus 1 over distance of object. So we can solve for this, 1 over the focal length. So we use the focal length that's on the same side as the object. And what that means is your focal length should end up on the other side. So it is actually a negative one that you use. So negative 7.5. I always have to look this up to know which sign. I don't memorize it. And then your distance of the object's in the right spot, is 20 centimeters. It's on the opposite side where the eyeball is. So we can rearrange this and we get 1 over distance of the image is equal to, and did I rearrange it? No. You know what? It's not a really nice one to fiddle with the fractions all that much. I did do some rearranging. I did a common denominator of 150 and then added them together and ended up getting negative 27.5 all over 150. You could punch in your calculator negative 1 over 7.5 minus 1 over 20. That would be okay too. Where you can flip this over, you get a distance of an image of, I worked this out before, negative 5.45 centimeters. So what that means is this distance of the image will be 5.45 centimeters. And it's on the opposite side to where the eyeball is. I like to think of everything should be on the side with the eyeball because you want the image where the eye is. It's kind of how my brain thinks about it. It's on the other side, this virtual image, so it ends up being negative. Now we work on our other part of the equation. Magnification equals height of image over height of object, which equals negative distance of image over distance of object. We can solve for the height of the image equal to negative distance of image all over distance of object times height of object. And what do we have? Negative distance of image, negative 5.45. And maybe you know that negative times negative gives you a positive, times the height of the object, times 15 centimeters, going into where I'm talking, but I think it'll be okay. And then we also have the distance of the object, which is 20. So our height of our image, if we use our calculator, if I did what I was supposed to do, punching it in, I got 4.09 centimeters. Then you can also look at the magnification, and you can go with the heights or the distances. And the heights, height of image over height of object equals 4.09 all over 15 centimeters. Should really put your units all the way through, just to let you know that's a really good practice. I'm not doing so well here, but I'm trying to be a little faster. 0.27. If you did magnification equals negative distance of image over distance of object, you should get the same answer. And that's a really good check to see if you actually got to all the right answers on this. Okay, so here is our very last question. And again, this is like about grade 11 physics. So pretty heavy level. So what do we have here? Well, we draw our nice baseline again. We have an object. Height of the object is 35 centimeters. And it says the distance of the object is 25 centimeters. It says it's converging. So I always have to think about this. And here's our converging. Because the concave would be the curvy on the inside. Convex is the curvy on the outside. So the spoon convex, converging, the backside of the spoon is such. That's how I think of it. So what do we have here? It also has a radius of curvature of 10 centimeters. So r equals 10. And then that means the focal point is equal to radius of curvature divided by 2. So 10 divided by 2, you're going to get 5 centimeters. Okay, so our next thing we get to do is figure this out. So F is equal to 5 centimeters. And we get to do the drawing again. So we draw right down, oh, this is not very straight, right down the middle of the lens. And we extend this past, and you're going to draw right across from the top. And then you're going to bend down. So now our focal point, we're going to have a focal point on the other side too. And we draw down through it. So there's our one part. Now our other part, we're going to go right through the middle of the lens. So we're going to go try to get fairly straight. At least you can kind of see, you can see I don't have great drawing at this point, but that's okay. So now we have our eye on this side. Now we get to use those same formulas again. And again, the trick is what is positive and what is negative. So what do we have? We have 1 over distance of image is equal to 1 over focal point minus 1 over distance of object, which is going to equal, what do you have here? We have 1 over 5. Now, this time, when the focal point is on the same side as the eye, that's where we want the stuff to show up. Is kind of the way I think of it. The image should be on the side of on the proper side of the lens closest to the eye. That's how my brain thinks about it. So it's going to be a positive 5. And then we have minus 1 all over 25. And if we solve for that, you're going to end up with 5 over 25 minus 1 over 25, which gives you 4 over 25. So distance of image is going to be flipped, 25 over 4, which will give you 6.25 centimeters. Now we get to calculate the other part, magnification, height of image over height of object equals negative distance of image over distance of object. So your height of your image, negative distance image all over distance object times height of object. I'm going to run out of room here, I think. So what do we have? A negative distance of the image. The image is in the right spot this time too. Okay, so it's positive. We want it on the side of the eyeball. So what do we have? We have negative, and then the distance is 6.25. Oh, get that negative back in there. And the distance of the object is 25. And you multiply by the height of the object, which is 35. And so we get a height of the image is equal to, I've got it round down here somewhere, negative 8.75. Okay, so there is where your height of the image is, and the negative is indicating it's upside down. Okay, inverted is what it's called. Now we can also get the magnification. I've run out of room, but it's pretty, there's not much more to do. Height of the image, negative 8.75 all over height of the object, 35. and I got a value and I punched that into my calculator of negative 0.25. So it's a quarter the size of the object and it's upside down. So that's how you do these questions. I mean, the big thing is what's positive and what isn't. That's kind of tricky. And getting comfortable with those fractions, you can see those fractions come up again and again. You can still use a calculator though. So anyway, that gives you a little sense on how to do optics. See you later.